All right, hello. Cheers, Kevin here, and welcome to a completely different game. This game is called While True Learn, and I received an email from the developers of this game with a Steam code to try this game out. It's in early access at the moment, and I'm excited to mess around with it. As you can see from the screen, this is a tycoon game that will give you the opportunity to take the role of machine learning specialist and develop from a rookie to a professional. So that sort of intersects with a little bit of my domain. I work as a software developer by day, not particularly in machine learning, but hey, hoping to learn more. We hope that our game will help you understand machine learning better. So I've played a little bit around with this, and we're gonna click through and kind of see how far we can get. I think this is a really fun game, and it's sort of in my wheelhouse, and I find it pretty addicting. So let's click on through. All right, so initially we are here. We are day 1 of 7. Our goal is to make enough money to feed ourselves and our cat. We have our coffee, always important, our little phone over there. I like the art style. There are startups that we can join and be participants in. But first, we have task 0, which is a school problem. Let's read that. So it says, and of course at Cheers Kevin at Cat Meow is my address. This is from Spanish School. They say, good morning. We are running a big social survey in schools and we've encountered a problem. Pupils often forget to mark in which grade they are in questionnaires. Can you divide pupils from junior and high school using their test sheets? Well, of course I can do that. It tells us we get these goals and our accuracy has to be 100% and we have to get things done within 35 seconds and we will make $500 for doing that. So there's private and startups and jobs. Right now we just have jobs, so let's accept that job. Ooh, and we get this deep news announcement. Every day since 1905. Non-neural artificial intelligence. Mankind has always been trying to create an artificial intelligence. Before the invention of neural networks, people used expert systems. Expert system is a deterministic algorithm which reproduces decisions of a real person in some cases. One of the examples of this is Eliza, the first chatbot in the world. It was created in 1966 and talked with the patient using questions similar to real psychotherapists. It worked horribly. Yeah, you can Google around and find Eliza on the web today, and it's interesting. I don't know. We'll see. Okay, so we're in this tutorial. Drag a block from the list. So we get these lists of little classifier tools, and we can place them on the screen. So really, we're kind of designing the data flow. Dragging the socket using your mouse to make a connection, and connect them using your mouse. So I will drag this into. So this is our input. We have 10 square red pieces of data and 10 square blue pieces of data. And we're just designing the user flow. So we're going to have an expert system that's going to find red items. And we'll say, go ahead and put that into the red bucket. And if it's not a red item, go ahead and put it into a blue bucket. Now, it could be in other examples where we might have other data that comes down the pipeline. And so throwing everything that's not a red thing into this blue output would be bad because we might end up with green or yellow or whatever. But in this case, we can see that we're only dealing with stuff that's one or the other. So everything that's not red, we can safely assume is blue. So let's click test run. And this is very, very slow. We can speed this up here. Thankfully. I also love Cat Hub coming soon. There's a lot of stuff that seems to be coming soon here. I'll be excited to see kind of when that's done. And okay, we have completed our test successfully. Occupancy is the amount of data that made it to the output on these two outputs. The first one, we got 9 of 8 pieces of data expected. Accuracy was 100%, and average destination time, it took approximately 5.1 seconds for every piece of data that got here, and 8.8 out of 8 there. So it cost us $42 because we had to pay for the server time that we took while doing the classification. We spent, there was 17% overload. We used one server to do it, and yeah, we spent 21.1 seconds out of the 35 seconds we were allotted. So that's works for our test. Now we'll do the actual release. And yeah, we haven't spent any money yet. We're starting off with $500. We'll pay $2 a second for our server time. So that's what, 20 seconds, $2 a server. So 42 bucks. Well, we saw that before. Go ahead and run through this and you can see how all that data was filtering out. So there we go. We have completed this and we're done. We get the Cat Cash Bank has rewarded us $500 for completing the job. We pay $42 for Cat Cloud time and we made $458 total off of that. So cool. Now another request comes in from Spanish School. We have some errors in our questionnaire data. We can't solve the problem. Can you fix it? Let's take a look. All right, so this time we have 3 pieces of data that are coming in, and what we need to do, it looks like, okay, so there's not really a description here, but we look at the output. It's desiring red and green squares, and the input is red, green, and blue squares. We need to have 100% accuracy, and we need to get at least 15 pieces of data inside here within the time limit. Well, we can do that again. We can look at the expert system. By the way, you can click these info boxes on all of these elements, and it says, okay, so here, the node compares colors. If the color of the element is equal to the chosen color, the element comes into the top socket. Others go into the bottom socket. And I really like this. It does say, before the invention of self-learning stuff, blah, 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 blah. It actually gives you these little links so we can learn how these particular things works, these particular elements work, and I think that's really great. So you can click through and watch a video or view a web description of these items, and that's really cool. What we're going to do is route everything into this expert system, and we also get a trash can. This node destroys elements. Real data sets have lots of errors. Filtering out errors is an important skill for all data scientists. Okay, so we're giving ourselves a second output, basically. What we're going to do is we're just going to say, let's filter out everything that is blue and send it to the trash can. Anything that is not blue can move on through, mosey on to our output. Let's test run. And success, so let's go ahead and release. And it's going to cost us $2 a second. There we go. All right, success. So we have made money again, $650 minus our cost. And we are good. So before we continue on, let's go into eBay, which I guess is the eBay in this cat-themed game. We can actually buy some additional things. Oh, actually, I don't think we can. Yeah, we can't buy most of these things. We can unlock things to improve the performance of our systems. We can also buy cat skins. But I don't necessarily want to throw a lot of money at that right now. So yeah, never mind. Let's go back to our next job then, I guess. Yeah, we still don't have any access to startups, it seems. Oh, wait, we missed the description. I would like to see the mail. Aha, okay, so 100% accuracy, 35 seconds, $650. Found some new types of errors made by our users. Please update your program. It will be easier if you use the previous version of the code. Okay, so this one, we could write it again, but what it wants us to do, I think it's gonna, if I try and do that, it's gonna get mad at us. Let's use our expert system and just say, okay, red goes to here, and then trash can goes to here. And if we test run this, it says, hey, in this task, you must use previous schemes. Change state to custom nodes. Okay, so this is a little bit, the messaging is a little bit confusing, but it actually, every time when we've been solving these problems, it gives this a little scheme name, and we get a custom node. It says you can use programs which you've constructed while completing previous tasks. Here you can see all the schemes made of basic nodes which are allowed to be used in this task. They don't waste time on transferring data from one node to another. So basically, we can take that whole thing, the whole solution to a prior problem, and treat it as a single black box. So let's do that. So this does without blue. Let's get rid of the stuff that we added here. We have red and everything else, and then we have without blue. So I think we can actually just chain these. These are actually our former programs. So let's see, if we did R and else, red, actually, well, we don't even need without blue. Red and everything else divide. Yeah, that works for us. Red should go here, and then everything else. We'll use our trash can. So that works, right? If we go here, yep, everything that's not red goes into the trash can. And all this is doing is it's using our prior solution to the very first thing we solved, I think. Let's go back. If we go back to this task, okay, this is an overlay message. Yep, R else divide is what it kind of gives this name by default. This is the classifier that we initially set up in our very first system. If we go through here, we're reusing the very same thing. We're just directing the output of it into the trash instead of into a separate output bucket. And yeah, so we can go ahead and reuse that. And in theory, with complex things, I think we'll be saving the transit time between these outputs and these inputs for these individual things if we have stuff that's more complex. So, okay, next project, we've got that one done. Lots of money. Okay, optimization of the code. Well, it's our last request. We have changed our database system. Can you update your code one last time? It must be faster. 18 seconds, 100% accuracy, $730. Okay. Now we need to make it faster. So what we need to have things complete in less than 18 seconds. I forget how fast we had things going before. only red is this. Actually, only red. Yeah, only red is that. That's our previous solution. How long did this end up taking to run? I forget. And you see, we don't have to have our trash can now because we're using that whole system. And it goes, oh yeah, no, that was way too slow. We only got 2 of the 8 pieces of data we needed. But we have this new thing, a decision tree. And this is one of the basic machine learning algorithms. Each tree knows a limited number of classes. When the decision tree gains an element, it asks the element some questions and chooses blah. That's real-world implementation. In this one, hey, the node compares the socket's colors with the element's color and chooses the socket with the minimum amount of errors. Now, what that means is that if we say here, hey, is this red or green? Well, if it goes through, it's going to pick, if we send a red thing down the line, it's going to go, hey, this has an error of 0 if we send it down the red path. It has an error of some value if we send it down green. But it's going to mean that blue values are going to be equally split across these. So what we actually need to do is chain some of these. And hopefully this shouldn't be too bad. So I'm going to direct the output in here. So this is stuff that we know is either green or blue. This is stuff that we know is either red or blue. And let's go ahead and just say green or blue down here, and we'll give it a trash can. We can have 2 trash cans or 1 trash can. I don't think it particularly matters. If it's blue, it's going in the trash. Oh, actually, hang on a second. Yeah, no, we don't need this side of it. What am I talking about? So yeah, assuming the things came through as red, that means it could be that we got red, or it means we could get blue, because blue is equally likely to go through either of these paths, because there's no way for us to filter on blue yet. So we're actually just chaining out all of those. So, and green can go into trash as well. So if we get classified as green, we go directly into the trash. If we go through as red or blue, because we're not filtering it out here, we go through here, and then blue will go directly into trash, red will pass on through. Let's test this one. And you can see we're actually getting some backup here, but that should be okay. Success. All right, let's go ahead and release that one into the wild. Test run complete. Next project. All right, 730, 702. Oh, and now we have a startup available. Let's do that. Let's take a look at that. This is Tatari by Geeks. Let's take a read. Good day. We are inviting you to join our hacker startup. We write cheats and guides for different games, but we would like to create something very cool now. We need a program that will play and win in Arkanoid instead of the player. We know you know a lot about machine learning, so we're inviting you to participate in our startup. So, my understanding is that I can invest some amount of money in shares of this company, and then I will do their machine learning stuff. Let's give this a try. I've messed around with this in the past and not done a great job, so we'll see what happens. The scheme created while working in a startup does not differ from a usual task one, but it can work better or worse. Your profit depends on the quality of the scheme. In startups, when you press release, your scheme starts to work automatically. Don't worry, you can get back to the scheme and change it at any time later. If your scheme contains self-learning nodes, you can disable learning in the test run. So that's something we haven't really done yet, but okay. Okay, so this one, this is a pretty simple thing. We just need to filter out reds and blues, and then filter out greens. We only have, let's see, only red fast is, okay, cool. Only red fast, nice. How fast are else divide? That is slow. This would take 0.3 seconds to get us only the red and automatically discard everything else, but that's not going to necessarily help us in comparison with stuff we could build from scratch. So I think we've got to do a chain of decision trees here, right? So we'll do the same. We'll do basically what we were doing before. We'll say red and blue, and then of course green, because it's not either of these, is going to have an equal error regardless of where it would try and classify it. So we'll have to filter those out. So we know that whatever comes down here is blue, or it could be an errant green. So we'll have to filter out the greens on both of these. Red or green. If it's red, great. If it's blue, great. Otherwise, go into the trash. All right, let's test that out. Now, of course, we need to have perfect accuracy, but there's not a metric for... All right, yeah, we're not doing too bad. We are lagging up a little bit here, but it says, hey, we're able to support... This is our throughput. We're able to support a fair number of users per day. That's not bad. And I wonder if this is this getting faster as we test things? Yeah, I think now it is. It looks like there's a lot of data coming through that pipeline. But you can see, because we've got this decision tree right up here, it's the one that's kind of the chokehold. It's even getting to this. We're getting this little flicker here saying, hey, this thing is backed up, but that's okay. Yes, okay, we're able to support a decent amount. We're paying $2 a second for server time. That's fine. Let's go ahead and release this and see what happens. From this moment, the startup will work automatically. Let's accept that. Okay. The money histogram shows the dynamics of weekly income. The number indicates the income received during the current week. The red column states that users brought you less money than you spent on servers that day. The user's histogram shows the dynamics of the number of users taking part in the startup. The number indicates the number of active users at the moment. If the number of users exceeds the bandwidth of your scheme, overload grows. The overload histogram shows the overload dynamics. The number indicates the current overload. If the overload gets massive, try to optimize the scheme. Cool. And we can see the amount of money the company has, and if the money runs out, the company will cease to exist. We can leave the startup and sell our shares at any time. So, cool. Launching a successful startup or successful completion of a task requires 1 day. In the end of the week, every startup provides you income. Cool. So right now, we've made no income. There are 100 people using our site, and we're not overloaded at all. And if we do another task, we'll have completed 1 more day, and we can actually see, hopefully, some money coming in. I hope. Let's see. Let's take a look at this system. Illuminati Origins from Strange Man. Cat meow. Illuminati Origins. I study ancient manuscripts and books in order to find the very beginning and truth of Illuminati's secret society. And we need to find all triangle figures in these documents to solve the puzzle. Can we do it using a program? Well, yes, I bet we can. Okay, so now we get SIFT. This is new. This block compares shape. If it is equal to the shape, then great, it goes in the top socket, everything goes into the bottom socket. This is the scale invariant feature transform. It's one of the most powerful non-neural image recognition algorithms. SIFT is very fast and may find simple objects and patterns. Cool. And of course, we can learn how this stuff works too, if we choose to. All right, so this one is pretty straightforward, this example. We go through here. Boom. And of course, this seems to filter out stuff based on its assumptions that we're not going to need them. The custom nodes, it's going, hey, that's not applicable. This libraries tab does not seem to exist yet, but I'm guessing it'll probably let us create custom nodes that aren't attached to particular solutions. Everything that's not a triangle can go in the trash. We don't even need to test this. This is just, I mean, kind of intuitively what we have to do. And we just have to hope that this completes within the time limit, right? Let's see. There we go. All right, 17 of 17, and we had a little bit of time to spare. Cool. Next project, and we get our money. Alphabet recognition. Good morning, and this is from KGB at bear.roar. Good morning, Tovarish. We know that someone from the USA created a system which can recognize the alphabet. You must create a copy of that system for KGB. The handwriting of USA spies is awful. All right, so this is something that needs to only be 40% accurate. It needs to go in 40 seconds. Okay, cool. Ooh, deep news. Every day since 1905. Rosenblatt's perceptron. First perceptron machine neuron was invented by Frank Rosenblatt in 1957. Frank created Mark I in 1960. Mark I is a perceptron machine that can recognize English letters by their shapes. Cool. I want to see real quick. Do we have any more? Oh, I bet we can actually buy some. Yes, we can. We can buy 1 megabyte RAM, which increases the socket's processing queue size, which means that we're not going to get backed up as quickly. That'll be nice. Sure, let's get that. Increased data transfer speed. That sounds great to me. Increased node work speed and data transfer speed by using the Rentium. Nice. All right, we've upgraded our hardware. And, oh, there we go. So our weekly income is $19. We have more users than we had before, but we're not overloaded. When we tested this, it seemed to be able to handle something close to 200 users at a time, at least. We didn't really test over that, but we can, I guess, jump back in there if we need to. I think I'm going to go ahead and leave it there for now. We'll probably jump back in with another video in a little bit, but I'm finding this to be very fun. We've got the perceptron, which is going to be interesting. This is something that actually is trainable. In test run, the perceptron reduces the amount of errors while trying to predict the shapes of elements. In the deploy run, it only predicts shapes. So this is one we actually train so that it becomes more accurate, depending on how much time we spend training it. And yeah, so that'll be fun. We're classifying out the 3 different items. We will tackle that in a future video. But anyway, this is a fun game so far. It's surprisingly addicting and entertaining, so I'd recommend checking it out. I'll have links for everything down in the description. I hope you've enjoyed this video, and if you have, likes, thumbs ups, comments, waves, all very much welcome. If not, there are plenty other videos you ought to be watching, right? The time is short, the internet is vast, so get hunting. I don't know what I'm talking about at this point, but have a great rest of your day, and I'll see you soon. Cheers.